Hello, ladies and gentlemen, and welcome to Calculus with Donald Trump. And so I'm starting with something very simple. We're going to start with some definite integrals. Here we are integrating the definite integral from 6 to 7 of x squared times cosine x. Now, because we're doing a multiplication of an exponent and a trig function, we're going to have to do integration by parts. You might know it as ultraviolet minus voodoo, and that becomes uv minus the integral of v du. So let's start simply with u. U is going to be our first value because I've decided it. Now, if you'd like to know, there are charts and such that tell you what you should decide each value to be most likely. We're going to make a u equal x squared. Now we're going to make dv, and we are going to make that cosine x. Stupendous. Now we need to find du. So that means we need to derive x squared. So we're going to find the derivative of x squared. Now, the derivative of x squared is always going to be something very simple. We're going to do the exponent rule, and it is going to give us 2x. Yay! Now, if you don't know what the exponent rule is, I don't know what you're doing here, man. You maybe need to go back to elementary school or wherever they teach Calculus 1, because you don't even know how to derive anything. Now, anyways, let's go back to dv. Now, in order to turn dv into v, that means we need to integrate v. So what is the integral of cosine? Well, that is very obviously sine. How do you know this? You either memorize it or you memorize the derivative part. In some way, you're always memorizing stuff for trigonometry. Yay, we love trigonometry. Okay, now we can plug into our formula here. So we have u, which is x squared. We have v, which is sine x. And then we're going to minus the integral of v, which is sine x, and the derivative of u, which is 2x. Yay! We've done so good. Now we need to simplify and ensure that we have a proper solution that we're not going to have to integrate anymore. Oh no. This is not good, ladies and gentlemen. What do I see? Doth my eyes deceive me? Is this a second integration by parts, I see? A second IBP within the primary IBP? This is ridiculous. No! So now after solving this, we've now seen that the integral of sine x times 2x is actually going to have to be solved by integration by parts. Oh my god, this is so crazy. So what we're going to do is, now this part's good, so this part we can keep. That's a very good boy. There's a very good boy right there solving that part. That's very good. So we can keep that, and we're going to put that on the back burner. Now we're going to have to solve this one. We're going to have to solve this again. Oh my god, this is crazy. This is so crazy. So we're going to need to take sine x times 2x, which is actually, this is actually a negative too, because we cannot forget that there's a negative sign. This is very important, because if you forget that, your entire equation is going to be wrong. Now we need to solve, we need to find what is u going to be and what is dv going to be again. Now u is going to be very obviously 2x, because what was it here? This was x squared. So then what is dv going to be? It's going to be sine x. This is very good. We're doing very good so far. Now we're going to need to derive u, which is going to give us 2. Yay! And we're going to need to integrate sine, which is going to give us negative cosine. Oh my god, this is so crazy. This is so crazy. I can't believe this. I can't believe that they're giving me a negative cosine. This is absolutely ridiculous. Oh my god. Now we're going to need to plug this back into our uv minus voodoo equation one more time. So once we plug this in again, then we're going to be able to combine everything together and solve it with FTC, Fundamental Theorem of Calculus. So that is going to be u, which is 2x, times v, which is negative cosine x, minus the integral of v, negative cosine x, times the du, which is 2. Now, simplifying this, it is going to give us negative 2x cosine x minus the integral of 2 of negative 2 cosine x. Yay! We have now solved this integral. Now, when we combine this and this, we're going to get x. No. Yes, no, yes. X sine x minus the negative 2x cosine x. And while we're at it, why don't we just integrate this really quickly so that we can simplify this fully? So we're going to integrate the integration of negative 2x sine, which is just going to be 2 sine x. Yay! Because the positives, they cancel out, and we're going to get a very nice little sine x. So now we can do plus 2 sine x. Now we need to do something really nice, and we're gonna have to actually plug in our definite integrals, because this technically right here is the final equation. And you could just slap a plus C on this, and this would be a stupendous final answer on any exam for free response. But if we were going to integrate this with FTC, Fundamental Theorem of Calculus, we're going to now have to plug in every single value, and we're going to see what that gives us. But this is going to give us a really stupid little decimal, so I will use a calculator for this. Now, since it says that 6 is our upper bound and 7 is our lower bound, that doesn't make any sense, actually, because 6 is smaller than 7. So what are we going to do? We're going to flip it around, and we're going to make the entire fraction completely negative. Yay! And that's going to solve it, so we can have put 6, 7 here, and 6 here. 6, 7. Now let's plug in our 7. Now what we're going to do here is we're going to make this entire value negative, and we're going to add the 6 value to it now, because we're very good people. Yay! Yay, we've now plugged it all in. Now let's just see what our values are gonna give us now. Let's put in another calculator. Okay, this is giving me negative 36 point blah blah blah. I'm gonna ignore decimal points. And this is gonna give me negative 3. Oh my god, we're gonna add those two together now, because it's a negative and this is a negative. And it's going to equal negative 39 and some change. Yay! We have solved this integral, and it's given us negative 39 and some change. Now, ladies and gentlemen, I hope you enjoyed this wonderful video. Please hit that subscribe button, or don't. I don't really care, but if you don't, I'm going to call Ice to your house, and I'm going to deport you.